Fusion Mobile, quality e-learning experience on the go.
You're welcome back. For our topic today, it is captioned sequence and series. Sequences and series. Okay, and so a series is formed by the sum of the terms of a sequence. A series is formed. Alright, a series is formed by this. Okay, some examples of a sequence is given below. Okay, of a sequence. Okay, we have examples of sequences. We have a series of 1, 3, 5, 7, and then okay, it's called a sequence. Alright, they are well defined, but when we add them, 1 plus 3 plus 5 plus 7, okay, plus 2 8 ends, it is called a series. Okay, so make, for instance, let U1 represents the first term of a series, and then U2 represents the second term of the series, while U3 represents the third term of the series and so on. Okay, what makes it a series or a sequence is because there is an orderly form of arrangement. Okay, if we look at the values we have here, we have 1, 3, 5, and 7, and each of them differ from each other with a difference of 2. Okay, the difference between 1 and 3 is 2, and the difference between digits 3 and 5 is 2, and the difference between digits 5 and 7 is 2, and so they continue in that manner. Okay, and it forms a sequence. What makes it a series now is when we apply operations to them, like addition. Okay, makes them become series. Okay, so just like we said, looking at the first term there, 1, U1 represents the first term. So just like in the example above, the first term is 1, and then U2 is equal to 3, and then U3 is equal to 5, because U3 is the third term, and then it follows in that order. Okay, we shall as well represent the sum of series by denoting by xn. Now if we want to find the last term of a series, okay, just like it follows U1, U2, therefore the last term we call UN, okay, will be represented as follows. Okay, represented as the third term of a series. Sorry, it will be represented as, just like the terms keep adding each other together, and so UN will be represented as arith term, of the sequence. I think we take a pause, and so on, so that UR will be given us, so that UR is the R term, and UR plus 1 x the Rth plus 1 term. Okay, alright, so we shall as well represent the sum of the series of by denoting with xn. Okay, sum of the series. Okay, sum of the series we denote by the term xn. Okay, there are two types of series. The two types of series we have are the two types of series. The two types of series we have, they are the arithmetic series and the geometric series. One, we have the arithmetic series, and number two, we have the geometric series. Okay, some people call it says arithmetic progression, okay, and geometric progression. Alright, we'll start up with the arithmetic progressions. Arithmetic progressions or series. Okay, we'll discuss this. Alright, the arithmetic progression, we have an example. We do this using examples. An example of an arithmetic series is given below as I'll denote with AP series. An example of an AP series is this: 2 plus 4 plus 6 plus 8 plus 10, and it continues. Okay, here you note that each term can be written from the previous term. Okay, each terms can be written from the previous term by simply adding a constant number, a constant digit, okay, to the next term, to the previous term, to get the next term. And if you look at the example we have below, you will find that there is a constant difference between digits denoted here, because there is a constant difference of 2. From 2 to 4 you have a difference of 2, and then from 4 to 6 you also have a difference of 2 digits. And so we will always denote a constant. We will always add a constant to get the next digit. Alright, so these are things you have to note. Note number 1, okay, that each term can be obtained. Each term can be obtained from the previous term. Alright, by adding a constant digit. By adding a constant digit. Alright, and then the second thing you have to note is that this constant value, or what I would call a regular increment, this constant value, or what I would call a regular increment, okay, it refers to as a common difference. It's referred to as a common difference. Alright, and so we shall be solving with examples, and so that you can understand better. Alright, so for example, if you're given a sequence, an AP sequence, example, if you're given an AP sequence, example 1, you have a sequence of 2, 5, and 8, and 11, and 14, okay, and so on. It continues that way. Okay, now knowledge from the regular increment, or what we call the constant, makes us to derive a general arithmetic series expression for this. Okay, I think the next slide will serve better, so we can have a clearer view of our illustrations. Example 1, we have a sequence of 2 plus 5 plus 8 plus 11 plus 14, and so on. Okay, So just like we said, knowledge from the regular increment makes us derive a general arithmetic series expression. Okay, as you know, if the first term is denoted as a, okay, good, and then to obtain the second term, we have to add a common difference d. Okay, a is equal to first term, and then the common increment or the common difference d is denoted as d and called the common increment or the constant value, okay, or the common difference. All right, and so the next value is adding 2 to adding a particular value to 2 to get the next digit, which is say is the constant difference a plus d. But in the case of this, you add 3 to a to get the next digit. Okay, and then to get the next digit, which is 8, you add a difference of 2 3s. Okay, you add a difference of 2 3s to a. Is that right? Yep. Okay, so we have a plus 2, the 2 times of the difference to a, and for the fourth one you add 3 times of the difference to a, and then the fifth one you add 4 times of the difference to a, and so the sequence continues in that manner. And if the sequence continues in that manner, okay, we'll get an expression for the last term. Remember that we said where a is equal to the first term, okay, and then d is equal to the common difference, and then we can say that the nth term, if we continue in this sequence, we can define the nth term to be equal to adding a difference of the common difference to a constant a, adding a particular amount of the common difference to a constant a. Okay, all right, let's find out. We shall try a sequence and then find out how this works out really. Okay, but ordinarily we say the nth term will be equal to a being the first term, and then adding n minus 1 difference to d. Okay, to give us the nth term. All right, we'll take a particular illustration and see whether it justifies this. Assuming just like the one we have above, we have 2 plus 5 plus 8 and then plus 11, and maybe the term is supposed to end at 14. Okay, can we say that 14 is as well the nth term being 14, that is n of 1 2 3 4 5, n5, which is the fifth term, okay, is equal to a being the first term 2, okay, plus n minus 1. N here denotes the number of items, n denotes number of items, okay, all right, and then number of items here 1 2 3 4 and 5, okay, number of items 5 minus 1, and then d, the common difference, as you can see, 5 minus 2 gives us 3. Okay, let's see whether we'll get 14. This is 2 plus 5 minus 1 gives us 4, 3, and then it is equal to 2. 4 times 3 is 12, okay, and then 2 plus 12 is 14. You see, it logically works out for this particular series, and so it applies to other arithmetic series. So we'll go into stating the sum, what it is defined as the sum of the first term, the sum of the first n terms of an AP is given as xn. Remember we said it's denoted as xn, n over 2 the bracket of 2a plus n minus 1 and d. All right, okay, so having made these illustrations, so I think we should have two things in mind, that the nth term of an AP, okay, if I say ATN is given as a plus n minus 1, okay, n minus total number of units minus 1 times the common difference. Okay, so this gives us the nth term of an AP. And so if we go through solving by examples, example 1, and we are told to find the sum of the 20th term. Find the sum of the 20th term of the series below. Alright, so how do we find the sum of the 20th term? The formula for the sum is in equation 1, and this is for the nth term in equation 2. Okay, and so we have to apply this formula xn to the series 10 plus 6 plus 2 minus 2 minus 6, you know, and it continues. All right, so solution, we are told that the sum of an AP is n over 2 and then 2a plus n minus 1 and then d. All right, so we have to define these items we have there. The first term there, a, is equal to 10, and then the common difference d there is equal to minus 4, and then the third term, the n there, the number of items, is equal to 20. Remember, you're told to find for the first 20 terms, and so x20 is equal to 20 over 2 in the bracket of 2 times a, which is 10, plus n minus 1, 20 minus 1, and difference minus 4. All right, and so the next line, we have to carry out some mathematical little manipulations, and then you could see from this point 2 can go into 20 to give 10, and then 2 times 10 is 20, plus 20 minus 1 is 19 times minus 4. All right, okay, so I think from this point we have 10 outside the bracket, 20 plus minus 4 times 9. 4 times 9 gives us 36. Okay, and then carry 3. 4 times 1 is 4, plus 3 you have 7, and so we have minus 76. And so we have 10 in the bracket of 20 and minus 76. All right, so we have 10, and so 20 minus 76 gives us all right, we have 4 here. We have 4, and then we have 5. All right, it should be 5, sorry, it should be 4 from this point. Okay, that's wrong. We have that 20 minus this gives us 10 in the bracket of minus 56. Okay, so we have 10 times minus 56, which gives you minus 560. So therefore the sum of the first 20 terms, the sum of the first 20 terms, okay, is minus 560. All right, so I wouldn't want us to start going to justify this, because it would really take time for us to find out whether this is correct or it's wrong. But we can use a simple example to illustrate that. Example 2, we just have to lift from the previous exercise we did, okay, where we said we had 2, 5, 8, 11 to 14. Okay, we have 2 plus 5 plus 8 plus 11 plus 14. Assuming we were to find the sum xn, which is 1, 2, 3, 4, 5, that's the sum of the 5 terms. X5 is equal to we have n over 2 plus 2a plus n minus 1d. All right, okay, so where n is equal to 5 for this, n is equal to 5, and then a is equal to 2, and the common difference there, d, is equal to 3. Okay, so we have 5 over 2 in the bracket of 2. A is the first term, 2 plus n minus 1, and it's 5 minus 1, and then the difference 3. Okay, fine. Have 5 over 2, and then we have 2 times 2 is 4, and then 5 minus 1 is 4 times 3. Okay, and then the next have this, and then you have 4 plus 4 times 3 is 12. Okay, and then 4 plus 12 gives 16. And so on the next slide you have 5 over 2 times 16. Alright, so 2 can divide 16 to give 5 times 8. Okay, and then 5 times 8 gives 40. Alright, so can we add these sums and see whether they give us 40? You know, when we add these sums, we have 2 plus 5. From 2 plus 5 we have 7. 7 plus 8. From 5 to 8 we have 7 plus 8 we have 15. Right, we have 15. And then 11 to 4, 11 plus 4 we have 15 again. Right, good. We have 25. Okay, 2 plus 5 we have 7, and 7 plus 8 we have 15. 11 plus this we have 25. Alright, and so 25 plus 15, 25 plus 15, 0 and 4. Okay, so you see that the sum of the first 5 terms there is equal to 40. So it goes a long way to justify. And so what if we want to determine the 100th term of the sequence? Okay, given that we have the sequence 2, 5, 8, 11, 14, and we want to determine the 100th term of the sequence. Example 3. Example 3. Okay, we're told to determine the 100th term, the 100th term of the sequence. Okay, the sequence 2, 2, 5, 8, 11, 14, 2, 5, 8, 11, and 14. Okay, and so we want to determine till the 100th term, and we don't know the 100th term. Okay, so remember that to determine the nth term of a sequence, you've been given the formula that Tn, okay, is equal to a plus n minus 1d. Alright, so T of 100 is equal to what? Where a for this is 2, and then n is 100, and then d is equal to the difference. 5 minus 2 is 3. Okay, the difference is the difference between each numbers in the system. Okay, just like you have 5 to the difference between 5 and 2, okay, is 3. The difference between 8 and 5 is 3. Okay, so you see the difference continues in that manner till the 100th term. Okay, so a is 2, and then n minus 1 is 100 minus 1, and d is 3. Okay, and then you have 2 plus n minus 1, 99 times 3. Okay, this gives you 2 plus 3 times 9 is 27, carry 2. 3 times 9 again is 27, plus 2 you have 29, 297, and then when you add to 297 you have 301. So the 100th term will be 301. What we mean by the 100th term, if you keep adding 2 till you get to the 100th term, the 100th term will give you 301. So T of 100, okay, is equal to 301. So we do this because of convenience, so that we don't keep adding numbers and then gets tired. Because if you want to do that before you get to 100, maybe you wouldn't have enough time to do the computations again. And so we're going into some other manipulations using the arithmetic progressions. Sometimes questions of this nature might be given to you. Okay, we can do one more example and then we'll round up the class. So we have example 4. Okay, now you ask that if the seventh term of an AP is 22, and the 12th term is 37, All right, find the series. Find the series. Okay, you see, we don't know the first term of the AP, we don't know the second term, but then we've been told the seventh term and the 12th term. All you can do here is to write out using the method for finding the nth term and then solve simultaneously. All right, I'll show you how you do that. Solution, you're told that the 7th term. So how do we represent the 7th term? T7 is equal to you have a plus n minus 1 d. Okay, that's if it's Tn. Therefore for T7 we don't have a, we don't know a. Okay, and then n is 7 minus 1, we don't know d. All right, so you can write T7 to be equal to a plus 6d. Okay, and then we call this our equation 1, and then we find the 12th term. T12 will be equal to we don't know a plus but we know n to be 12 minus 1 and then d, and so we have T12 to be equal to a plus 11d. Okay, so this is my equation 2. All right, so therefore I have 2 equations I can solve simultaneously. Either I use my substitution method or I use my elimination method. So I have T7 to be equal to a plus 6d, and then I have T12 to be equal to a plus 11d as the 2 equations, 1 and 2. But from the equation you find out that T7 is equal to 22, and then T12 is equal to 37. From the equation, look at the equation again. So I can rewrite my equation to be equal to 22 is equal to a plus 60, and then 37 is equal to a plus 11d. Okay, so this makes it easier for me to solve simultaneously, either by substitution or by elimination method. You can as well switch your formula to look like this: a plus 60, okay, is equal to 22, and then a plus 11d is equal to 37. It doesn't really affect the equation. Okay, I'll solve by elimination method. I've solved these two by elimination method. Okay, because that's the easiest one for me. All right, you can apply substitution method if you like. By elimination method, all right, with the subtraction sign here, a minus a is 0, and then 6 minus 11 gives me minus 5d. All right, and then 22 minus 37 will give me minus 15. All right, and so therefore I can say that minus 5d is equal to minus 15, and so minus takes care of minus, therefore d will be equal to 15 over 5, and so from this point 5 into 15 gives that d is equal to 3. Okay, so now that I have d, I can substitute d into any of the equations above, into any of the equations 1 or 2 to obtain the value for a. So if I decide to substitute d in equation 1, we have that 22 is equal to a plus 60. Okay, so if I, and knowing that d is equal to 3, okay, and then I substitute d equal to 3 in equation 1. All right, so I have 22 is equal to a plus 6. Where I have there replace as 3, and so I have 22 is equal to a plus 6 times 3 is 18. So that when I move 18 to the other side of the equation, I have 22 minus 18 to be equal to a, and 22 minus 18 is equal to 4. Okay, so therefore we can say that a is equal to 4. All right, so we now have that the first term of the sequence a is 4, and then the common difference is 3. All right, so let's try to formulate the sequence and see whether the 7th term and the 12th terms are 22 and 37. All right, so that means the sequence you're talking about here, with the first term a being 4, okay, the next will be 4 plus 3 being the common difference, which is 7, and then 7 plus 3, which is 11, sorry, which is 10, and 10 plus 3 is 13, And 13 plus 3 is 16, and 16 plus 3 is 19, and then 19 plus 3 is 22. You see, the 7th term is 1, 2, 3, 4, 5, 6, and 7 gives 22. And then the next term, we keep adding till we get to the 12th term. Plus 3, you have 25. Plus 3 again, you have 28. Plus 3 again, we have 31. Plus 3 again, we have 34. And then plus 3 again, we have 37. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the 12th sequence is 37, and the 7th sequence is 22. Alright, you see, this is a sequence we are looking for. Okay, so the sequence we are told to find is this. Alright, and so from this point we're going into discussing a different topic. We're discussing a different topic altogether, the topic that is titled geometric progressions. We're talking about geometric progressions. Alright, that will be in our next class. Okay, at this point in time, I have to say thank you for being part of the class. Do join us for some other classes. Study and be blessed.